Okay, good morning, everybody, and welcome to lecture 15. I hope we can do this at once, not in 3 sessions, as it happened with lecture 14. I think almost the whole class is in. Maybe 2 or 3 people are still missing, but we have to go straight ahead into the second part of interior systems, in which, if you remember, last lecture was more about construction, whilst now we are elaborating more on the interior environment, especially passive systems, right? Because from tomorrow on, probably we will go into active systems. Your favorite part, MEP systems, which we have to deal with. But today is conditioning we can do without support, without support of machines. Okay, so let's go into it. So we will start having an introduction, as usual, about how we relate to the environment and our basic vital needs. I think the whole class is already in. As I'm speaking, people come in. I said I wouldn't let people in at any time, but I keep letting people in. So after introduction, we will continue with the basic solutions, which is the three basic parts. It's not all, but the basics: ventilation, light, and acoustics. Acoustics is a little bit more technical, but if you pay a little bit of attention, probably it will not be much difficult. Before we enter into the lecture itself, just a small reminder, still some people are missing the assignment 2.0, right? So I make sure the submission can be done till Saturday. I think final day was tomorrow, but I put one more day. So please upload the assignment, and please upload only once, right? So make sure you choose the right file, because some people said, oh, I sent the wrong file and I have to resend again. So it is kind of a waste of time for you and for me, because it takes a lot of time to review every assignment, and you have to do twice. It's kind of wasting time. So just be careful about it, please. If you upload twice, I will just consider the first thing I see, okay? And that's it. Tomorrow, as usual on Fridays, we will comment on the following assignment, which for which we have 2 weeks, which is, you remember, it's about the envelope, which I think it is the most basic, most important part of the systems we have to deal with, apart from the structure. But structure is a bit more simple. And hopefully you will finish this week, right? Remember that the assignments I receive on time, I will review over the weekend. I will try to dispatch as soon as possible so you can work on them. You can still submit for 1 more week, but those who submit late will have just grading, not feedback, okay? So let's go into the test first. Let's do it fast. You have 1 minute to do it. And fortunately, the whole class, I think, is in, so we don't need to wait for anybody. So make sure you do it. It is not easy question, but interesting for me to see. For quite some time. Okay, please start. Those who didn't start yet. Okay, almost everybody is in. Please, those who didn't start. There are 2 people still out of the check. Okay, almost everybody did. So let us remove this. Okay, it's closed. Those 2 who didn't start, sorry, you will be late. Hope you come later to the class. And now let's continue. There's a question here. Yes, assignments. I don't know why you're confused, but only 2.0 is okay with computer, right? 2.1, 2.2, 2.3, 2.4 are by hand. And final is free, right? It is explaining at the beginning. And no, that's not the point. And it was very clear. So listen carefully and read carefully. It was only assignment 2.0, right? And if you go to the guidelines of the assignments, it is written again. So please, please read the guidelines you have, the checklist you have in the Blackboard, okay? Okay, and I explained already the why it is done like that. It is not me being crazy about hand drawing. It is just to make the assignment useful. So you can go back to the previous lectures, to the introductory lecture at the beginning of the course, and you can see about it, okay? Good, thank you for asking. So let's start by thinking about the interior environment. And we have some vital needs. After all, we are living beings. Sometimes when we design, we think on people as an abstract beings, as numbers, as a kind of a computer game elements, but we are living beings. We have a basic vital needs. We cannot change that. We already commented that with the previous lecture, we have a lot of things we can do, but still we need to fine tune further, right? So let's see how we relate to the environment. The first thing we notice is the vision, right? And almost the totality of the population relies on sight, on the eyes, for everyday activity. That means that the visual design is important, and we are aware of it. That's why lighting, natural lighting, artificial lighting is important. But we have to be aware that even though most people rely on vision, about 3% of the population, and it depends very much on countries, this is very much wide statistics, have some visual impairment. 3% is a lot of people, right? It's quite considerable. And this is where we have to be very careful in design. There's an example of a Seoul subway, right? And the lighting is perfect. The degree of light is good. The signs are lit. But you see that design is a bit more subtle. So we have a nice, very well done color coding, right? So line 5 is kind of a blue-purple, but we have contradictory information on the side. So to go to the line 5, we have to go to the left, but we have the same purple going to the right. And of course, nobody listens to it, right? So this creates confusion. So this is about the signage, but color coding is just one example, and signage on how we are not always so careful with the visual orientation, right? And there's something which has to deal with design. So in the Seoul subway, we have every day about 300,000 people, Samsip Man, Myung, using the subway. And probably this kind of signage is confusing a lot of them. So how we deal with the vision? So basic is lighting, right? We try to use natural light as much as we can. Where we cannot, it's artificial, and sometimes mixed is quite a universal solution. We need adequate light level, so the intensity of light, not too much, not too little, right? So too much light is creating glare and making us actually even damaging our retina. But we need enough contrast to see things, right? And often we don't take care about those things. Of course, we have the signage. Ideally, design should be done in a way that people can find their way without signage. But still, we need basic information about the main entrance, about toilets, about elevators, about the floor we are, right? So the signs and the lettering need to be clear and be properly lit, and to have a proper contrast and proper size and so on. And finally, color planning. Color has a lot to do on the intensity of light or the level of lighting in a room, right? Not only in the mood. Of course, the mood would be the subject for another lecture, which we don't have enough lectures to deal about it, but surely you already studied, or you can find many sources to see how different uses of color may change or may affect the mood of the use. But color here is mostly about this correct vision. This is an example of the construction of a KT Tower by Renzo Piano in Gwanghwamun, right? And you see here the color. Of course, Renzo Piano and many Italian architects love white, but even white have infinity of white colors. And RAL is one European standard in which we have like a very precise guides with all the subtle differences of colors. You can produce the same color. And this is interesting because colors are what they are, but we perceive differently depending on the light, on the reflections. Especially white is very tricky, right? But you should actually, when you say a color, you should fix some standard and then check on site how it works. And this is a correct way of doing. See the sign. This is Eco Water Paint. It's not painted. It's like too many letters right there, right? This is in English, so the people from the main office in Italy probably can understand what is happening there. But see the choice of using water paint with well, Eco, we should see the label, right? Just a side comment to remember what we saw in the previous lecture and see how important design offices, architectural offices, take care of those small details. I give you the reference. In Korea, I never saw the RAL color. I saw many US catalogs. So America have their own way, and curiously many Japanese standards, right? But well, the one we use in Europe is mostly RAL. Then you see the signage. Because here they say only the font. Actually, Avant-Garde is a 1970s design. Very popular among architects because it's very minimalistic. It's based just on circles and straight lines. So it's very square lettering and very neutral. And Renzo Piano is already old guy, so this is the style of lettering of his time. Right? But this is just checking that sign can be read on some distance. See also the floor number. So before deciding the final lettering fabrication, you have to see on the place how it works. On the glass, you see reflected your sombre, which it was done at a time in which we could visit the construction sites. But this year we had only 30 students in class. So it was very easy to find the construction sites who allowed us to come in. Right, so the visibility is first, we have to have the proper size and then to give proper contrast. And I annotate why graphic designers enemies. I don't know why, but since the 1980s, it seems that the graphic design making smaller signs and smaller letters and more light makes things more cool. But actually, things become much more difficult to read. Right? Seoul subway is quite modern, but Madrid subway was probably 1919. It's over 100 years. In the 80s, they renewed all the signage. And one of the things the designers did was to make a cooler, more elegant, smaller signs. And for a few weeks, people were lost because they could not read. So the size is important. This is an example of size. This is a Tokyo subway. Well, this is not subway, the railway. This is, I think, Shibuya, famous Shibuya station. And this is a recent renewal or renovation of the toilet. And you see the signage is quite large. Translation is fun. So you can see at a distance of probably 4 or 5 meters, the logo can be understood from much more far away. This is like larger than we are used here in Korea. But still, in this case, they had to add much, much bigger, because after people asking and not finding, they put a much larger sign. This is not cool, right? But it is clear. And this is what I said about the conflict of graphic design with the importance of communication. Of course, when it is crowded, people will hide the lettering because we try to put the letters at eye level. So you see horizontally. This is why large signs over are important, because you can see when the station is full of people, which happens very often. So also the position of the sign is important. I didn't mention, but this could be a nice exam question to see how many people were listening at this point. This is another example, and this is here in Korea. So Korea, the Korean Railway is making an effort to have elegant and modern stations, but I don't know why. They have this habit of a blue sign over blue glass, which makes the signage most of the times invisible at daytime. Probably, of course, this is a corporative identity, but you have to deal with this contrast, right? At night, it's okay because it is lit. And the size is okay. The position, I'm not sure, because the main interest of Cheongan extension is a bit ambiguous, but that's another matter. Contrast is important. There is one more thing, and this is a famous, important public facility. And what is this building about? Yes, it looks like a shopping center, right? U Square, which is the name of the building, and you have all the restaurants and the shops inside. And we only have a tiny signage telling this is the bus station of Gwangju. If you are a local and you live in Gwangju and you know the place, it is okay. I don't have no problem. I think nobody's waiting. Just a moment. Okay, everybody's in. So this is a bit crazy. In bus stations, many people which are not from the town have to find their way. And I I'm not sure this is the proper way to use the signage. So probably there's a competition between the bus companies and the railway to see who makes the more confusing and the most invisible signage ever. Then we have sound. Sound is the main means of our communication. And see that communication is a very hot word in Korea. Everybody speaks about communication for almost anything. So communication is mostly through sound and speech, mostly. Again, the statistics is almost the totality. Only 0.5% of the population need to resort to other ways of communication. This is why sound is so important. But in this case, about 10% of the population has some hearing disability. And that makes our use of acoustics not only to have proper sound, but also sound insulation. So sounds are not mixed. You may have this experience of being in class and hearing the professor in the other classroom distracting you because the sounds get mixed. Or to having too loud speaker with too much resonance, so that makes the sound even more distorted and so on. Unfortunately, the hearing impairment is growing worldwide. The general use of the headphones. Some people have the headphones like all day long with high volume, makes the ears to lose sound sensitivity. So the proper design we make on sound is really helpful to allow for this communication. And probably acoustics is one of the most neglected issues in architecture. Right. Even in auditoriums, in a big auditorium, you call on a specialist and be careful, but places like churches, we are very careful with light, for example, with the space, but usually the sound is not as controlled as happens in all churches, which they already have the system. So the way the ceremony is done and the music is created is related to the acoustics of the existing spaces. But the new modern churches have often terrible acoustics, and that happens also with the very famous churches spaces. Auditoriums are a bit more plain. Theaters, people, as I said, call specialists, but even a small classroom, a bedroom, a hospital space needs a care of sound, right? So, as we said, it is very neglected. So this was just a street musician in Tokyo. Tokyo is, this is Tokyo, right? Tokyo is a noisy and active city. It's about the noisiest in the world, but it's surprising that some people can find a space to play music on the street. Whatever, the right sound conditions is part of our work, and it is very, very neglected. One example, which we have seen now with the pandemic, so many people going to the ICU rooms, right? And you know, hospitals and sick people need silence for their own healing, but often the ICUs are the noisiest places in the world. Of course, the nurses, the doctors need a lot of alarms and to be informed of how the patients do. But to spend in this case, many people spend like a month or weeks in the ICU, day and night with all that noise. Even if you heal, probably you have a mental damage afterwards. Then we have the textures, right? So visual, we understand perfectly because in the end, we consider ourselves designers. Sound, we can understand, but the textures are like a very far away thing. It's not just a visual characteristic. It is very important for the visually impaired, not the totally blind necessarily. Of course, the totally blind will rely mostly on tactile impression. And if we want to be really universally accessible, we have to plan the spaces in a way that those people who have not vision as the main way of navigating have other clues to walk around. And of course, textures, shapes, the texture complete the perception, right? And also for the general population, we just look around and how the pavement is designed and how textures are done, we understand the pathway, right? This is DDP. Actually, it is interesting, the barrier-free inspection allowed them to have the non-standard pavement, but well, that's a good merit of the designers who work in DDP, right? Because, well, I'm not sure. Because this using yellow is also for the people who can see to some extent, but need a higher contrast so they can recognize the places, the shapes faster or clearer. And this was fortunately corrected, but still, this is an innovation building in Korea University in our campus. And we have the path for the visually impaired, and this is the door which is locked at night and on weekends. It has been like that for probably over 10 years, right? Until they finally corrected and changed it into the proper door, which is usually used. This is not a problem of design, it's mostly a problem of management. There's a very poor way of locking the doors, by the way. Probably lack of design. Also, they have a lock, but this is so primitive in a building which is called itself innovation. It's like a middle age enclosure. So many contradictory messages happening around. One thing we almost never use is a smell. And you might find some efforts to make, for example, smell mapping of towns. And as you navigate, you walk around, the smell makes you recognize places, right? Here in Seoul, it is very clear when you walk near the school and you cross towards the east and you approach the traditional medicine market, you have this smell. If you go a bit farther, probably south, you have the meat market, Yadmajan, which has another smell. In the morning, it's like the rotten market, not so pleasant smell. But if you go at night, you have the bulgogi smell, and so on. So smell gives you information of where you are, and could be also a possible aid to give orientation, not only to the visually impaired, which they will also thank if you take care of that, but for the general population to have a more complete characterization of the environment we are. And this is urban environment, but the small scale landscape you do in your buildings and the gardening and so on can also relate, and of course the interior. By the way, remember that a healthy building or healthy building, that's interior, do not smell, right? So the smell of new apartment smell is probably pleasant to many people to say it's new apartment, a new car, new whatever, but this is all the chemicals you are smelling. So the less one interior smells, the better. You may have the smell of timber or the small suggestion of the wet earth when you're using like a clay walls and so on. Those are natural smells which again give character and relate us to nature, but that smell of glue, of plastic is something that probably we had better avoid. So as a conclusion, actually this was my studio one long time ago, probably 2012. buildings are just to hold human activity mostly. And since we're human, we have to support all those vital needs, right? Which is more than just square meters and furniture. In this case, people are talking, so you need to have an environment in which this conversation can happen. You see that the communication is talking, right? As we said, most people communicate by words. I bring one drawing by one of my professors, Sainz de Oiza, maybe the most important in Madrid, born 1918, right? About same time as Louis Kahn. He traveled to New York in 1947. It was like the first era of skyscrapers. And he was so impressed with the mechanical systems of the buildings that he made a beautiful drawing just summarizing it, which is explaining the buildings work really like a human, with the lungs which collect air and send to the rooms and then eject outside the air. Actually, it is getting in, right? Getting in. So it's like the air intakes and then the dispersion through the building. Not only the metaphor, but see the pain he took to draw independent system for the basement already, with the air intake from quite far from the ground, so you don't have all the pollution of the street, but also the big space those systems take, right? The machines are huge and the pipes, the ducts take a lot of space. As it happens in our body. So our lungs, in terms of volume, make one very large organ, right? That happens in buildings. So the space needed for systems and machines is something we cannot ignore in our projects. Of course, a skyscraper will be more penalized because you have a lot of vertical elements, so you will lose a lot of planet space. But in horizontal buildings, you will need a lot of roof space for those horizontal ducts, conductions, and so on, right? And of course, the machine rooms. And this is one of the things we will try to deal with in next lecture and following lectures. One interesting thing, which is a reference, is the rule of 3, right? So this is quite classical. We need 3 minutes to breathe, depends on the people, but usually 3 minutes is the critical time. We need to warm within 3 hours, otherwise we get hypothermia and we can just have a fatal consequence. We need water at least within 3 days, is the limit, and food within 3 weeks. Of course, water and food we didn't talk about. Supply of water and food are also part of our design. We need to put storage of food, supplies, refrigeration, cooking, and that adds the same as water supply, right? We have a new need, I didn't comment, but we need like 3 seconds within data. If we don't have our data every 3 seconds, we cannot work. And I would challenge how many of you did not look at a mobile phone messaging or whatever information they have in the time of the class. We are already half an hour into the class, and probably most people looked already a few times to their mobile devices. Let me know if you did not touch at all, didn't look at all your mobile phone, just write it in the chat. And of course, we have a conflict. This is the air in Seoul. We have some of the more terrible days in the world, actually. So for air, we have the ventilation. So for water, we need not only drinking, but sanitation. We need a water supply, and we need to take the waste out because we have black water, and we have also the cleaning ourselves, the hygiene, or the cleaning of the houses and so on. For food, as we said, we need a supply storage, but also cooking, eating, and waste disposal, right? And this cooking and storage, even supply, also make a lot of conditioning in the way we design buildings. Think that cooking creates a lot of smell and gas, right, fumes, and it's very difficult to isolate from the rest of the building. So sometimes this becomes a headache. You all have the experience of the food courts. One of the problems of food courts is the smell of different kinds of food going away from the court, and so getting mixed often with the cleaning of the dishes, which happens in the same space. So you have a strange smell of different foods, and also the cleaning materials for the dishes, right, the solgoji. And that's really not always pleasant thing. And in restaurants or large canteens, and so we have a hard time finding how to get all those smells from the kitchen not mixed in the rest of the building, and especially in the dining room. Of course, the shelter, this is already what we saw, so we don't need to continue into that, right? So after this introduction, we know the problem is complex and there are many things we ignore. Let's see what we can do. What we can do in 40 minutes. First thing is ventilation. Fortunately, we already speak about it, so you can go to lecture 10 and see what we said about natural ventilation, which I think was not extremely detailed, but probably all the basic things you have to consider about natural ventilation. Tips, especially for climates as extreme as Korea, in summer is the cross ventilation. So if you have a building and you can have the air crossing from side to side, you will have always some air movement. It will be easier for the air to renew. This is why rooms with two windows in different orientations, something that, for example, Frank Lloyd Wright did very often, right? He tried to make important rooms with 2 or 3 facades. Also, you will have one space with sunshine, heated, another cooler, and that will make also some kind of air movement. Probably in that case, the movement would be in the opposite way, right? And cross ventilation is something that Hanok did very well. You have these signs. You have a big opening to the south, but a small opening to the north. So in summer, you have all this cool, fresh air going through the house, and you have a very, very fresh maru and very fresh space where you can be, right? See, think that also in Korea, because of the Punsucheri, you have always a hill on the back. So all the freshness of the forest, of the hill, will help this cool air, right, coming inside and having a better environment. One example, which is very different, I brought an example from Spain. This is the south of Spain, Guadix, is near Granada. It's in the south. This is a place that, because of the character of the ground, it is very easy to carve. And you have, for cross ventilation, we have a question. No, so the question is about, in this cross ventilation, if you need one opening to be smaller than the other. No, this is just a case of Hanok, right? I exaggerated a little bit. And you know, Hanok, the winter is very cold, so you try to have protection. But in summer, probably just having small openings is enough to have the air moving in, right? In the case of Japan, Japanese house opens totally to all sides, right? Because the climate is different and the custom is also different. Okay, good. So I brought an example of Spain. I could bring many examples from Turkey or Middle East, right? In which they have this system. And in this case, they use the natural stack effect. So you will have windows, and you see usually from the cool side, right? And then chimneys, so the difference of air density will make the air enter through the windows and move around the house and get out through the chimneys. So even though you don't have so many openings, the house is well ventilated. I couldn't find many sections, but I found some, not another town, again, is Spain, so the same area. This is a floor plan. Actually, curiously, it is like two different houses, right? So they don't have this cross ventilation. It is all based on the vertical ventilation of the stacks. And the height difference makes this air movement more effective, right? There are rough ways of calculating. Most people, I never calculated this. I never worked in this kind of architecture, but I think traditionally it's just a practice, right? So this is the place they use for cooking. It's great because you have the heat of the fire, but all the toxic gases go out, right? And that cooking also pushes more fresh air inside, because just the air going out makes a void. Just the difference of pressure, even if you have wind, will make the air come in inside. See how this also makes the obligation of having the rooms connected, right? So the air comes around, and surely this another vertical opening in the bottom room. This system is used also in modern architecture. This is Arup over Arup, one of the most advanced engineering offices in the world. And in this case, it's just letting the air in, having openings between the floors, and an exit, which is, again, using the height. And I would bet if this is south hemisphere, then this is the south. So the sunshine comes from this side, right? So you have shade, you have indirect light, and you have the air getting out on the cooler side of the building, well, on the not heated side. But this heating of the sunshine will also help the air, hot air going out and sucking, pushing the air coming through the building. When you make your diagrams, right, make sure those arrows showing the air have included the window or the openings, so we know what you are doing. Often we see a very solid building full of arrows of air moving around, but there is no way to know how this moves. So you have to give a suggestion of how this happens. Because you'll see here a solid wall, but this is accompanied of other diagrams telling how those slits, automatic slits, work, right? We already commented about Alhambra, I will not repeat, but one thing which is important is the evaporation. And this evaporation happens, you need to have a very dry climate. So I wonder in Seoul, for example, we have a summer with almost 100% humidity. In that case, evaporation will not help, right? But in Granada, we may have 15%, 20% humidity. And then the evaporation is very intensive. It's a big surface. And that evaporation absorbs a lot of heat. You know, the change of the state between solid to liquid, liquid to gas, is the physical change that absorbs most energy, right? So in this case, it's very effective. And it is surprising how much cooler those courtyards are. You may have almost 40 degrees outside, and maybe in the courtyard, maybe 32, 33. And you would feel even cooler because of the contrast. You will feel like really, really cold, right? Of course, if you're in the sunshine, that difference will be not so large. You need the shade also to work with it. So evaporation is important, but be careful on the climate because it doesn't work everywhere. Let's move into lighting. Now we have 2 quarters of an hour. So we have 1 quarter of an hour for lighting and 1 quarter of an hour for sound. Let's see if we can do it. Natural lighting is not just about having too much light, it's about having the proper light. And it is beautiful, those Dutch paintings. This is Vermeer, I don't know of the spelling, Delft. And the Dutch school, in which they show those windows which give the right amount of light for the work those guys are doing, right? Often we just are too radical and we put glass everywhere to have plenty of light. It's not just the amount of light, it's the quality of the light we are putting inside. If we want to have the proper light, this is the section of a room. So this would be a 1 person, probably, right? Fat person with a window, light coming from the window. And of course, as we get far away from the window, the light level decreases. If we need an acceptable light level, we need to add artificial light. So we have artificial plus natural. But this is what this diagram is telling only. We will try to have as much as possible, at least daytime and acceptable daylight. But in many cases, that mixed light is hard to avoid. One note about adequate light. We have this fixation with the south, which comes from the apartment marketing. In a house, you will look in the northern hemisphere, and a climate like Korea will look for the south orientation to have plenty of sunshine for basic healthy life and natural heating of the spaces. But in offices, that direct light is just giving glare, right? And overheat, because we have already computers, machines heat, and we have overheat. It doesn't work. You know, computers with the sunlight, direct sunlight, you cannot see the screen. You're overhot. That happens. Imagine yourself in the bus with the sunshine, right? Even in winter, it's unpleasant unless you're very, very cold. So, in a curtain wall, south, and I would add southwest and even west are hell. West is a hell in southwest, are hell in summer, of course, right? But south in winter, I have the experience of office buildings in Seoul with minus 10 degrees outside and the air condition inside because it was so hot with the sunshine. And this is why you have so many buildings built in Seoul. This is a small tower in Yangjae. I saw the construction, and just the day after it was finished, people started blocking all the windows, not only because of the signage, which is a Korean custom, but you see, even without signage, all blinders are down because there's no way to use that space with so much sunshine. We commented this, but this is something which appears in all exams, right? Just try to play with the quality of the light on every direction, every orientation. So south is great for heating and living, but not great for work, unless you are reading books or doing some kind of manuality. North, which everybody in Korea tells us are dark, north is not dark. North is not dark, but cold, right? Which is good in summer, but the northern light is among best we can have. And even better if we have reflection from a clear wall in front of us. West is great for like Eastern baths. So that Oriental habit of getting the bath in the afternoon and the evening makes to have a heated room, right? Especially Southwest in winter. But West is the most difficult in offices, right? So Southwest, we said winter baths, winter bedrooms, you have that chance. This is taken from the Roman handbooks. Imagine you have an office building with the north, right? In summer, you may have sunshine from probably 4 or 5 a.m., depending on the buildings around, and may go down probably at 8 p.m., right? The question is, and this is noon, right? The question is, people start working usually at 9 a.m., right? At that time, in the morning, still the morning is cool, the sunshine starts hitting the building, but after probably 10 or 11, there's no more sunshine, and it is not so heated. But after 12, it's already hot, and the sunshine is still there, like 8 hours, heating and heating the space. So the afternoon heat is much, much worse. So many hours of sunshine in already hot hours of the day. Right? And that will also overload your systems, because those guys on the west will need a lot of cool air, and those guys will be overcooled. And if you don't cool everything, the building will not work. So you will need to divide in zones so everybody has the proper cooling. I have my office in the innovation building. So innovation building is probably not this kind. Okay, so it's like this. So this is northeast, this is southwest. My office is northeast. It's very pleasant in the morning. I have some sunshine, but those guys in the southwest have sunshine the whole afternoon. So in summer, they put their conditioned like crazy, and I need to have a winter jumper because I freeze in my room, even in full summer. More about light. So we have to consider that reflected light is very important, and the one we use most often. Direct light, especially sunlight, we will try to avoid at all costs. Reflected light has 3 components. Sky diffuse light. This is like the light we have where the sun is not hitting totally. We have reflected light from surrounding surfaces. And this is what I tell him. We may have a house with a north window with a white wall. There's another building. This sunshine will hit the front wall, and you will have a very nice reflected light inside, whereas you will have very strong glare and contrast in the south side. So this environment will give you very, very nice light. Often we mimic this by creating some screens on the front so the light diffuses, and then you have a nice reflection. You have very, very regular light all over the space. So this reflected light is important. And then inside the room, this is where the color of the walls and floors enters into consideration, right? Because that reflection will change. You already studied in other courses one technique to improve the light on the room is just use this reflected light. So you avoid direct light, but that reflection will have like a very, very regular intensity through the whole room. Light shelves, forget this. This is not, I have to correct it. Light shelves are great, but they are both a little bit complicated to detail, to build, and to maintain, right? So detailing, building and detailing complicates quite much. So they're a little bit expensive, and people rely to fluorescent light, which is much cheaper, much faster, easier to do. For this to work, of course, you need to have the surface clean, and cleaning those light shelves is not so easy, right? You need a lot of maintenance, and public buildings and schools are not an example of maintenance themselves. So this is the weak point. But this is one of the best solutions you can find around. You have some examples of using a design, what I told you. If you design regarding the sun movement, you may have always indirect light, but you may have a much better, much more constant diffusion than you will have with a flat surface. And sorry about this, I forgot to so to have a reflection, you will need to consider the colors. there is nothing like a 100% absorption. It doesn't exist. There is only the moth, this night butterflies, moth eyes are probably one of the few elements in nature we have totally 100% absorption. So they can see at night very much. All the light comes in the days and doesn't go out. In reality, we cannot go so far. And also it's very difficult to have the 100% reflection. Most of the elements we'll use are in this area of the scale. This is a scale of the reflectance with different colors. So reflectance and the solar reflectance index is different. This is about heat. Yeah, reflectance is about light, which is not exactly the same. They are related, of course, but not exactly the same. And you see that the whitest we have, Snow White, will go almost 80% of reflection. And we don't have the pure black, but blacks will go probably 10–15%, the best we can do, right, in absorption. So you have a scale. Of course, depending on the colors, the reflectance is different. That depends on the wavelength. This is physics. We will not elaborate on that, only telling that the visible light is around there. If we have several different tonalities, it may change a little bit, but we always consider the white light as a reference, right? And we know white is pure white is just an ideal. In all the analog design, if you don't want to make simulations, it is common sense. The higher the window is, the more deep light you have, right? The light will go farther. Making the window to the floor will not change much unless you have the floor reflection, and then that may improve the general lighting. But as we say, the direct light on the floor may be glare problems, and you have to be careful about it. But the way to have a good lighting is to have high rooms. We have another question. Oh, this is an old question. Why roofs are painted in green? Right. The short question, I don't know. Right. This is a local culture. In Spain, for example, Spain will mostly paint them in red. And I guess this is kind of imitation of the tiles, because traditional room is a clay tile, and that to give the image. Probably the Korean green is to have that kind of green roof. Of course, it is kind of clean and so on, but I think it's a problem of image and design. In most cases, and if you go to the LEED or the New Korean sustainability standard, which is just a mix of the American and the British, they will give you points for white roofs, right? Or green roofs, but the real with the plants, not with paint, right? Plants are different because they give shade and the process is different, but this green painting is, I think, just pure cultural image of what we do. So to summarize this slide, the higher the window, the better. Traditionally, we think that twice the height to 2.5 times the light is the acceptable area in a window. This is why with a height of 3 meters, which is most we have in a house, we think on a depth of up to 6 meters is acceptable, right? With 2.5, which is more the Korean standard, you have like a 5 meters of a room depth, which works with the general design. Top lights have very much efficacy. The plan of top light is, as usual, the direct heat. So the top lights will have some kind of device to avoid this direct light and to have some kind of reflected inside. So you have the light and not the heat. You have the proportions with the level. You will never go so far as half the room, right? but actually top lights, if well distributed around the room, give almost perfect light. But the problem of the top lights is the heat, right? And also getting this indirect light. Light wells is something we see not so often in Korea, but we have very much in Europe, because many houses have small wells in very compact construction. And usually acceptable is like the 45 degrees. Yeah, it's like a very much basic rule of the thumb. The width is more or less the height, and that's kind of acceptable. You see the 6th floor gets, well, not red light, but still you get a reasonable amount of light, right? Under that is almost to the extent that the lower floors may have some ventilation. Yeah, that's another matter, but not really light. So to improve that, you work with the diffusion. If you can make the light diffuse, that's amazing, but the diffuse light is very regular and will go all around without much loss, right? So I didn't see this very often, but actually it works quite well. Works much better than mirrors, right? That you will see. You have mirrors in Ihwa, the Dominique Perrault underground building, right? But mirrors need to be cleaned, and they work only with direct light. Diffusers, diffusing, need less maintenance and give much more regular light to the interior. Other thing which is important or interesting is the pipes. In a small distance, you may have a lens which collects the light from the outside, and very reflective pipe, which may give a light to one room, which may be between 1 to maybe 4 or 5 meters from the roof, even lower. You have a natural light, almost perfect, but you will have the quality of the whole spectrum of light. I say almost because many of the light waves are already absorbed by this mirror, right? So it depends on the quality of this mirror, the light will be better or worse. But this is quite cheap alternative to give natural light to rooms in which it is impossible. You might find, this is from the internet, so you might find a few makers who sell it. More interesting, something which happened in the 1980s, right? Which is optical fiber. It started in Japan. Himawari means sunflower. So they have those devices. You still can find them in the market. So you Google Himawari and you will see the whole system and even the prices. The solar cells are just to feed the motors there. So they have natural light capturing elements, and that will be transmitted by optical fiber. And in this case, you have almost the full spectrum of light going to the point B, and this can go much longer. You lose, of course, with the distance, but we can go 50, 60 meters without much lost. There are more patents after that. Patents is Swedish, and they tell about up to 100 meters, but of course there's a loss, right? And for what I understood, you have also Korean makers using the license of Himawari, but I'm not sure about it. This is used in some of the underground spaces here in Seoul, but I should check because I'm not sure how they did in the end. So you have, it's the same as a light, as a lamp, but this is like a daylight. Of course, at night, it will be dark, and in cloudy days, right, you will have a cloudy interior, so you have less light, which is nice because you have some connection with the exterior, even in a basement. So this kind of change of mood and light quality will happen also inside the building. So to at home, I invite you to summarize what we saw about different orientations and different kinds of rooms to see which is better. And that in your design may help you take decision on how you place the windows or where you locate those spaces. Let's go to the acoustics. And we have just a minute for this. Well, let's not hurry because acoustics are tricky. And we have to know about the characteristics of sound. Reverberation is basic in our design. And of course, so the conditioning, which mostly is insulation. So our condition is about getting proper insulation and proper reverberation, so we can hear clearly. So sound is a wave. So the frequency is based on how much those waves are wide or low. So this is a high pitch, right? And this wider wave is a low pitch. And then bigger waves make more intensity, right? So intensity and pitch are two basic characteristics of sound, which we are all familiar. We have also the quality of sound, but we will not go into that. What makes a human voice or instrument voice different? Here, just the physical question of pitch and intensity. So today, the reference is the frequency of 440. This is the musical La or A. I cannot sing, it's too high for me. Around there, right? So you see that you have most of the sound is around this wave, right? And only very extreme elements go in the very low frequency and the very high frequency. Human hearing goes between about 15, 16 decibels, hertz to 1600. When you have the sound hearing tests, usually check between 20 or so to about sometimes 18, sometimes 1600, right? So some places even the doctors consider it's not critical because most of the sound happens a little bit in a narrower spectrum. And yeah, so in music, you will go very seldom under this space, right? So most of the human speech and human voice is around this area. The harmonics are interesting because this is like a sound by sympathy. So harmonics have one frequency and some frequency which has exact number of waves, or has a what would be here, right? Relation is the harmonics. They amplify themselves, and that happens with fluorescent light and also with LED light. They have vibrations, also transformers, electricity, everything which is vibrating can interact with sound, and that may be a problem, especially with transmissions. Right. This is why sometimes we have strange sounds in the transmission in the computer, just because something is just entering in resonance with the harmonics of the sound. So the problem with the sound is that each frequency, each pitch is perceived in a different way in terms of perception and intensity. So we need to use averages to simplify. And one very common is the pink noise. It's a standard mix of frequencies which relate to usual noise, right? Not the annoying noise, but just the soft noise we have in the environment. And this is why we use also decibels. So decibels are a way to measure sound intensity. It is a bit tricky. Let's see if we can go into this before we finish the class. So 1 decibel is 1/10 of a bell, right? So it is like we use logarithm. One importance of logarithm is that our perception, curiously, of light, of sound is not linear but logarithmic, right? We need to have a big increase of the physical phenomenon to have this perception ourselves. So this is a logarithm of a ratio between a basic intensity and the real intensity of sound. E0 is just the basic intensity of a mosquito, right, humming at 3 meters. This is something that many people will not hear. I'm in the limit of being possible to hear. You lose hearing with the age, and in the tests, I'm sometimes between 0 and so on. And now